So we're trying to figure out the age of a sample of something based upon radiometric dating. All right. And radiometric dating is basically figuring out how old something is by figuring out some stuff about the decay that has gone on in the sample. All right. All right. Here's a definition. And by date, it means like to figure out how old it is. All right. Using the decay of a radioactive isotope to date something. All right. It's often used with rocks, often with fossils or artifacts, and you're essentially asking this question. Now, in order to figure it out, right, what do you need to know about the sample? Well, since it's on radioactive decay, you really want information about how much decay has happened. All right. And the way to figure out how much decay has happened is to really look into the concentration of your parents and your daughters. So, because at 0 half-lives, 1, 2, 3, 4, 5, I'm going to have 100%. My ratio is going to be infinite. This is parent to daughter because I've got infinite parent compared to daughter because I have no daughter. Then it's 50-50. Oh. So my ratio is 1 to 1. Then it's 25 to 75. My ratio is 1 to 3. 12.5 to 87.5. That's 1 to 7. Then it's 6.25 and 93.75, and it's 1 to 15. All right. This is ratio parent to daughter. And finally, it's 3.125 to 96.875. Yep. And that's 1 to 30. The ratio is 1 to 31. All right. You could think of all this data in another way. You could think of it as like a timeline where I start with 100% zero daughter. At 1 half-life, it's 50, 25, 12.5, 6.25, and 3.125. And then it's going to keep going down and down. All right. This isn't anything new. It's just another way to see the information. That's a 1. All right. And these are going to keep going on and on. 1, 2, 3, 4. All right. Sometimes people like this kind of timeline as a way to visualize the data. You can use either of them. And once you have this information, there's 2 formulas you're going to use. And one being your percent parent, or your percent parent or daughter is the parent divided by the total. All right. And percent parent plus percent daughter should be equal to 100, provided that you don't have subsequent decay happening. All right. And that your half-life is this times this. All right. Half-life times the number of cycles. That's the age. Did I say the half-life is this times this? The age of your sample is the half-life times the number of cycles. Let's go over a couple problems. A rock's got 38 parents and 42 daughter. How old is it? Well, it's got more daughter than parent, so it's definitely older than 1 half-life cycle. And I've got a total of 38 plus 42, which is equal to 80, right? That's the total. So 38 divided by 80 is going to be a little bit less than and then you're going to multiply that by 100. I didn't write that on the formula. Percent parent is like that. All right, you got to make sure you multiply that by 100. 38 divided by 80 is going to be a little bit less than 50%. I'm going to pause this. So I did it out. Our percent parent equals 47.5%. So if you look at our timeline here, where does that put us? 40% is like right in here. All right. So I could say something like 1.2 half-life cycles. Half-life equals 1.2. And then let's just say my half-life is 15 years. It should have been given in the problem. All right. Then I would multiply 1.2 times 15, and I'm going to get like 17 and change, I think. 18 years. All right. Now this 0.2 is kind of, you might have said 1.1, and there is a more exact way to get the amount based upon like this, but we're just going to, for right now, for our purposes, we're just going to use estimates. All right. A rock has 30% parent, all right, and it's U238. How old is it? Well, 30% parent is, it starts at 100, 50 to 25. So 30 is like in here. It's almost through 2, but not quite. So I'm going to go the half-life cycles equals 1.8. My half-life, since it's uranium-235, sorry, uranium-238, I would need to find what's the half-life for uranium-238. It would be given to you. This half-life is 4.5 billion years. So my age is half-life times cycles. So 4.5 billion times 1.8. I get 8.1 billion. So times 10 to the 9th years. And that's how you would do it. All right. Thank you. Hope this helps. Let me know. Give me some comments